coordinator, and that he has passed it on to Mr. Tom Totten. And I forced him to come tonight by saying that he was going to come and support Chuck, but little did he know, I have an award from Mr. Art Harris. I told him I'd give him a hug, but I was liable to fall on top of him. And we'll get a speech from him later. Thank you, everyone. Back to you, Jerry.
Okay, well, this is a good opportunity to purchase something from our vast storehouse of merchandise. Because I think we're going to be voting next month to possibly raise the prices on these things to help us with increased costs. So strike now, the sale is on. Okay, next we're going to have the outreach coordinator, Chuck.
Quiet months this month. We've already had a couple of nice cloud outs. And coming up, we have Lopez Lake tomorrow, but nobody answered me about camping, so we didn't arrange any campsites, but I guess I'll just go up and give them a slideshow tomorrow. And then on the 21st, third Friday, it's our normal third Friday at Westmont College. And then normally we would be going to Refugio State Beach, but they're still closed because of damage from the storms and things. So we're going to be at El Capitan State Beach, not El Capitan Canyon Resort. And we'll be in their day use parking lot, which is very similar in some respects to how we set up at Refugio. It's just a little higher up away from the ocean, but it should have pretty good views and good conditions. So that's on Saturday the 22nd.
So we told the gatekeeper that we're with the Astronomical Unit?
Yes, they should just let us right in if you tell them you're with the Astronomical Unit, and even the public coming to go see it. And then we have another one on the 29th, so a week later on Saturday. So it's a pretty quiet month. And then for July, we have on the 4th, we're going to do I believe, I haven't really heard confirmation back, but I think we're going to do a July 4th star party at Bacara. And from the spot where we set up, which is by the Angel Oak on the bluff over the ocean, you can see the fireworks at Gersh Park, and you can sort of see the fireworks from Santa Barbara too, although they're kind of low on the horizon. So assuming no marine layer, we'll be out there having a star party. And then we'll have largely our usual summer stuff with Kachuma Lake starting up in a bunch of the Saturdays and Refugio in a bunch of the Fridays. But that's for July, so thank you.
Oh, I wanted to wait till you got to your seat. Actually, we're going to have the Baron come up here and introduce you.
Oh, Jerry, we might want to cut to the events here.
Oh,
The potluck coming up on July 5th.
Oh, yes. On July 5th, we're having a potluck here at the museum. So we need to sign up in advance. We have some people signed up. Food is usually pretty good. The conversation and companionship is great. And here comes our event coordinator.
Hi everybody, I'm Diane Welsenbach, and I know Pat wanted me to come up so that everyone knows who I am. That way if you wanted to sign up for events, or if you have any ideas for events, or if you have ideas for a place to have an event, certainly bring all of those ideas to me. Be happy to hear them. And like Jerry was saying, we have a potluck on July 5th, and it'll be here at the museum, at the Broder facility, which is just right across the creek to the left. And it's not imperative that you sign up, so if it's the day of and you decide you can make it, please come anyway and bring a dish to share. So thank you.
the other speaker. And I hope I can remember this. Somebody I ran into recently is thinking of joining our club, who is like most Americans, love astronomy. And it dominates the news for science except for medicine. Everything else pales in comparison and follows them. They asked me this: okay, you got this long-time club. Who's the heart and soul of your club, SBAU, Aaron? And I thought about it and I said, well, the heart has got to be Pat McPartlin, and the soul is the guy doing our speech tonight. Of course, the captain of the starship just left the stage. That's the inimitable man in charge who we love. He's the guy in charge. But other people might be, let's see, on the starship SBAU. Our radio man would be Andy Allen, who is our secretary, keeping everything in charge. Is Andy here? Yeah. There's the man. I'm not sure where I put Diane. Well, as far as her part on the ship, you know what? She's not the heart and soul. I'm not sure what I am. But Mr. Spock is Tom Cotton. I'm up there, yeah, I know, but as far as, let's welcome the man who's going to do a Lunatic Express ride around the moons, Mr. Chuck McPartlin.
One age before the other age.
Okay, like Jerry said, this is kind of bait and switch, in that John Winkowski wasn't able to be here. And let's see if I can get my presentation going here.
You want to share with them probably, right?
Yeah. All right, we got to do the share first, I think. So it's kind of bait and switch. John isn't able to be with us. And Jerry asked me to fill in, and I said, great, this is my chance to make sure that nobody ever asks me to give a presentation again.
Oh, nonsense.
So I tried to mimic what John was going to be speaking about, which is moons in our solar system. I'm probably not covering the ones he covered if you saw his presentation at Dargan's. But I picked a representative set. We're going to hit some of the big guys, but we're going to hit some of the more obscure moons. And I figured we're going to go all the way out to Eris and Dysnomia. So it's about 8 billion miles away, and we've got to finish in an hour, so we're doing at least 8 billion miles an hour, which is faster than the speed of light, so that's not so bad. So I didn't take these pictures, because if I did, the planets would be crooked and the polar caps would be cut off, but these come from real live people. And so this is a tally of known moons plus unknown moons here, but with the known totals added up, it's 297, but there's really way more because we keep finding bunches, especially in the asteroid belt. There's at least 20 so far in the asteroid belt we know of that have moons, and that's even discounting binary asteroids, which is sort of a moon-type thing. Saturn is the big winner with 146 moons at last count. And these are all, lower bounds, so if you memorize any number, it's going to change. And then, I threw in the dwarf planets too, what the heck. So we've got some moons there, Haumea and Makemake and Eris. And then those are really part of the Kuiper belt, kind of, out there, trans-Neptunian objects. And the farther out you go, the slower things move, so the more likely you're going to get them pairing up in moons. So I think we're going to find a whole bunch out in the Kuiper belt, and then even more out in the Oort cloud. And some of these have been found in the asteroid belt, the Kuiper belt, and the Oort cloud, with what I do for fun, which is asteroid occultations, or occultations of small solar system bodies, where they pass in front of a star and make it wink out. And if you see it wink out twice, you've got a binary asteroid or something that's got a really weird shape. So there's a lot of them here, and we're going to try to cover a bunch of them. So I want you to think of this as though you're sitting on the Pacific Surfliner, okay, and it's going up the coast, and you're watching the moons go by as you drive up. And speaking of rear our rears. This is our moon. We're going to visit that first. And this is the far side of the moon. You don't normally see. This is from one of the Russian Luna spacecraft. And you can see the Sea of Moscow there. Is very few mares on the back side of the moon, and but a much thicker but less dense crust. So it looks like you have all these impacts that form the mares. There are mass concentrations there, and that's the side that got tidally locked to the Earth. So the moon rotates around its own axis in the same amount of time, roughly, that it takes to go around the Earth, and so we pretty much see one face. It wiggles, so we see about 60%. And most of the major moons in the solar system are also tidally locked to their parent planet, so it's not an uncommon thing. This is the way our moon will look tonight at 9 o'clock from the NASA Goddard Space Flight Science Visualization Center. You can go in there and enter your date and time and see what you're going to be seeing. So it's pretty much a first quarter moon. You can see the mares on the front end. We've got our soccer player on the moon there. His head is kind of in the middle with his nose pointing up. He's got his torso going off to the right and his arm coming down and his soccer ball up above him. Just to give you size, the soccer ball is about 350 miles across. That's the Sea of Crises. His head is the Sea of Serenity. His torso is the Sea of Tranquility. His lower torso is Sea of Fertility. And I think his arm is something like the Ocean of Rain. But don't quote me on that one. My wife, Pat, knows better. She knows the moon stuff. So people have always made features there. There's a little feature down in his elbow, kind of, or just in his shoulder there that looks like a fish jumping up to grab a little cookie. And down a little, right there, there's a fish grabbing a little cookie. That's where Apollo 11 landed. And our moon is the only place people have gone to. We only did it 6 times with people. Over 50 years ago, we're talking about going back. And this is Apollo 11. And I've heard recently some good news and some bad news for the crazies who think we didn't land on the moon. And that is that indeed, who's that filmmaker? 2001: A Space Odyssey. Kubrick. Stanley Kubrick did indeed film this moon landing, but unfortunately for him, Neil Armstrong demanded that they do it on location. You can see why nobody will ever ask me back. So we think the moon, the best idea for our moon's formation is that it was collisional. It's something about the size of Mars, smacked into the proto-Earth, spalled off a bunch of stuff. Basically everything got molten and sprayed out. And then several moons congealed out of that, and then they condensed with each other. They had slow-speed collisions. And that's trying to take into account the lithosphere on the moon that's a lot like ours, the much smaller iron core, and the angular momentum that's still left in the system. And there's a recent simulation that's been done, and we actually have a baby picture. There we go, a baby picture of our moon, according to this simulation. Oh, yeah. Okay, now we'll move out to Mars. Mars has 2 small moons, Phobos and Deimos, Fear and Terror, the companions of the god of war. Phobos about 13 miles across, Deimos about 7 miles across. Phobos is in an orbit where it will eventually smack into Mars. It's decaying. So in about 3 billion years, you can watch for some fireworks. They're both, they look like potatoes in a BB gun shooting gallery. They're covered with a deep layer of dust, it seems. And you can sort of see that here. You'll really see it on Deimos. And there was a mission, Phobos Grunt, that the Russians and European Space Agency were going to do to go land on Phobos. That one kind of went kaput. But I think the Japanese are planning on a mission to go there, coming up and land on Phobos. And it'll be a nice sort of way station, as almost like a satellite that you can go back up to if you want to return samples from both Phobos and from Mars. So see how that works. Deimos, really covered with dust, thick layer. And they both are kind of low density for a solid rocky body, so they seem like they might be rubble piles. And you've got people that say they're captured asteroids. You got a recent story, somebody says, oh, they might be captured comets, but the orbits are kind of clean a little bit. And the case that you might capture 2 things is kind of small, I think. So it looks a lot like the other theory for them is like for our moon, that they formed collisionally from whatever came in and smacked in and made the Hellas Basin on Mars. Okay, well, now we're in the asteroid belt. This is the first moon of an asteroid discovered by the Galileo spacecraft as it was heading out to Jupiter. This is Ida and its moon Dactyl. Dactyl is something like a mile across, that little dot there. Ida is something like 30 miles across, so really low gravity here. Probably formed collisionally again from something that smacked into Ida, and the debris coalesced to form Dactyl. If you were standing on Ida, you could probably take a good running jump and make it all the way to Dactyl, but if you miss, you know, it's a long way. And then the last asteroid that the moon discovered, the latest asteroid moon discovered, as far as I know, is with the Psyche mission that's heading out to the Trojan asteroids around Jupiter. They had a lucky discovery. They turned on their cameras, and there was this moon Dinkinesh that they found, this asteroid Dinkinesh that they found that they could go visit, small asteroid. And it means wonderful in Amharic, which is the Ethiopian language. And Psyche is, oh, I'm sorry, this is not the Psyche mission. This is the Lucy mission, not Psyche, Lucy. And Lucy, going to the Trojan asteroids, they look like they're pieces of the early solar system, like fossils, and it's named after the Lucy fossils that was found in Ethiopia of humankind. And so their logo is a skull. And Dinkinesh is the Amharic term for wonderful, which is what they call a Lucy fossil. And as they were going by it, they took a picture and they saw a little moon start to pop out from behind it. And then as it got farther away, they took another picture and they saw that it's a contact binary moon. So this is two moons in one, but they're in contact, so it's just got one name, Salam, which is peace in Amharic. So it looks like a lot of things out there are binary or, you know, either in contact or very close orbits, some of them similar in size, some of them disparate in size. So there's lots and lots of moons out there. Pretty soon people will argue what's a moon, what isn't a moon, just like they did for Pluto. And we'll have Saturn up to a couple of billion moons. Galilean moons, so these are some of the big guys. When we get out to Jupiter, this is at the top there, yellow is Io, and then to its left is Europa. And then below to the right, the big one is Ganymede, and then the other one there is Callisto. These are the 4 Galilean moons. They got him in big trouble 400 years ago because he could tell they were orbiting Jupiter, and that was a big no-no back then. In size, Io is about the size of our moon. Europa is about the size of our moon. Ganymede is the biggest moon in the solar system. It's a little bit bigger than the planet Mercury. It's about 1.5 times the diameter of our moon. And Callisto is smaller than Ganymede, but bigger than either Io or Europa. And we've, of course, had the Galileo spacecraft out there orbiting around, and it was able to do some gravimetric measurements of these guys. So this is what we think their composition is. Io is a silicate moon with an iron crust, an iron core, and then a silicate crust. Europa has a silicate mantle and an iron core, but it's known for its icy coating, and then an ocean, a saltwater ocean that has more water than there is on the Earth. And then if you really want a lot of water, there's Ganymede. And then Callisto. So these moons are in resonance, which is about the same thing as being tidally locked. They're in resonance with each other, so they don't interrupt, they don't mess with each other, because they've been there for billions of years, right? If they mess with each other, they get tossed. One of them would get tossed. So Io goes around in about, let's say, 2 days, Europa 4, Ganymede 8, and Callisto 16. And so that resonance keeps them from interfering with each other in that respect, but it causes tidal friction on the inner moons. So Io and Europa are kind of getting flexed a lot by this tidal friction. And so Io is basically, it looks like a cheese pizza, full of volcanoes. It's the hottest surface temperature outside of the sun in our solar system. And those nice colors are caused by this sulfur-rich lava that's being pumped up from inside. And actually, I like Io because when I was at UCSB, I was commuting and going only Tuesday, Thursday, and I was trying to get a lot of classes that fit in so I wouldn't have to drive so much. And one of the professors I had for an astronomy class was the guy who predicted the tidal flexing and heating of Io and the volcanoes just before they were found. They were found in 79. And that was Stanton Peele, so that's pretty cool. There's things that look like olives on your pizza there. Those are the vents of the volcanoes. And recently there were some nice pictures by the web, I believe, of some of the lakes of lava there on Io. But the really cool picture that just recently got released is this one. This is Io from a ground-based telescope. Yeah. So this is on Mount Graham, the Large Binocular Telescope. Just got incredible views here. I'm sure there's some processing going on, but still pretty fantastic. So didn't have to go in space for that one.
How big was the telescope?
It's like two 8-meter mirrors. So 8 meters is like 24 feet. And they combine them somehow. It's not really an interferometer, but they combine the image as though it's a larger mirror, but losing a little bit of the light. And they probably have adaptive optics. Everybody has that now, even if they are in a great place to do it. The only thing they have to worry about is squirrels. There's apparently an endangered species of squirrel that lives on Mount Graham, so they have to limit how many cars go up and how many people go there and who could visit. So make sure you plan ahead if you're going to go there. And bring some peanuts. Europa is also getting squished and squeezed a little bit. That heats up the interior. That's what gives us that liquid water ocean. It's got like I think it's estimated to be 20-kilometer thick icy crust. But as it gets squished and squeezed, that crust cracks and moves around, stuff oozes up. This is a color enhanced picture to show you sulfate and magnesium salts that are oozing out from the cracks. You don't see very many impact craters. There's just kind of one down there under the box. And it's resurfacing itself. And the fact that it looks bright white, visually, tells you that, hey, there's stuff going on here that keeps the surface young, because ice in the radiation environment around Jupiter turns black. So you can tell that this thing is busy. And there's the JUICE mission that's, I think, not quite launched yet, but getting ready to launch, the Jupiter Icy Moon Explorer. That's going to go take a look here. They're real careful not to land on these moons because they don't want to contaminate them. That's why they sent Galileo down into the atmosphere of Jupiter and burned it up. So we're going to learn more about this. They've taken all kinds of measurements gravitationally of the interior, and it looks like a really interesting place. And with the temperatures that it would have in there in the water, and with the chemicals that they have, it's a place that could potentially harbor life. And so is Io. Even though it's kind of nasty, but there are extremophiles that live in Yellowstone, with the hot tub type environment there that could live on Io. Ganymede, again, biggest moon in the solar system. It's doing most of the squishing and squeezing, so it doesn't have quite as much activity, but you can see some sort of tectonic plates of the ice here. And the younger areas are brighter, and the new impacts are brighter, and then the older areas are turning dark. It seems to have a magnetic field from the core, so again, an interesting place, but it has a thicker crust, so it'd be a little harder to try to drill down and see what's going on in there than it is for Europa. I'm looking forward to a probe that goes to Europa. They were talking about having one with a nuclear source of heat that they could, melt their way down into the ocean down below, and I was waiting for the camera view of a big mouth. That's an impact that spread debris there, so you can see that sprayed out splat, like the seagull on your windshield. Callisto is where you go if you really like craters. We think it's undifferentiated. I didn't talk about that when I was showing the interior. But we think that one's undifferentiated. It's not undergoing the squishing and squeezing out there, and so it just has an amalgamated rock and ice core with an icy crust for some reason. It must have differentiated a little bit, and then not much goes on there. So it's mostly dark ice, and except where craters have hit, and it's like crater central if you like craters in the solar system. Okay, so now we're going to go out to Saturn, And Saturn has a big moon called Titan that we used to think was the biggest moon in the solar system until we figured out Ganymede was slightly larger. And it's really interesting because it has a thick atmosphere of methane and nitrogen, which is what we think the Earth's atmosphere was like up until like 2.93 billion years ago when algae started to pump oxygen out into it. So that makes it a fun place to go look. And also it has a hydrological system, much like we have with rain and liquid on the surface and lakes and stuff like that, except it's liquid methane and ethane, liquid natural gas, minus 300 degrees. But when you got stuff like that going on, you have an energy source that a life form could take advantage of. So this would be a life form that can take advantage of a metabolism that uses those energy levels. But at minus 300 degrees Fahrenheit, it's going to be something that moves pretty slow. But it's real interesting. So when the Huygens probe, this is the Huygens probe, but when the Cassini division, when the Cassini spacecraft went out there, they dropped off this Huygens probe from the European Space Agency to go down and land actually on the surface of Titan. And this is going to be a little obnoxious, but this, I know Ron always asks to see this. This is the video of them coming in and landing, and it's got some ugly noises in it. They basically sonified it so that there are noises whenever they take a picture in a certain wave band, and the wind speed, and the altitude, and how much they're spinning. And you can see them gradually as they come down through these cloud levels. It looks like they're going to land at Lake Kachuma. So that green line is their altitude above the surface. You can see how the wind changed when they entered and pushed them over, started taking pictures. They're spinning around like crazy, so they're building up an image, and they're still in the clouds, so there's not much to see. So they're taking spectroscopy, because they're taking these pictures in various wavebands of the visual and infrared. And they are also measuring the strength of the radio signal coming from Huygens back to Cassini, and that's shown on the right near the bottom where you see the green heartbeat with the little red lines. So they're using that to measure the atmosphere and the cloud levels, the cloud densities. So you can see they're starting to see some surface features here. And similar to with the moon, these darker areas seem to be the liquid places, although on our moon it's not liquid. We used to think that. So you can see the terrain. The mountains and the rocks are water ice, and the dark areas are lakes and mud, basically, of methane. So if you go there someday, you're going to have to bring your own oxygen to breathe and be careful with your matches. There's a little line on the far left, bottom left corner that shows the height of Mount Everest. So we're getting down near the height of Mount Everest above the surface now, and starting to see a lot more surface features. Yeah, it's kind of cartoonish. They've stuck together a whole bunch of different bits of data. Definitely the soundtrack for a cartoon. And they actually plop down into a swamp, basically, into some methane mud. And it looks like it's a riverbed. And you'll be able to see there's actually rounded rocks of ice. And at that temperature, ice is like rock. So there was flowing methane there that had caused, these particles to rub up against each other. So you have erosion and all kinds of things. You have riverbeds. Not very many young craters. The thick atmosphere protects it from impactors. And the weather, they don't have gophers, but they have wind and rain. One little area they haven't gotten an image of yet, but they'll eventually get there. left is a view of Armstrong's footprint on the moon to give you some scale, but it's not actually a footprint on Titan. Not yet, anyway. And of course, Cassini's getting farther and farther and farther away, so eventually they're not getting the signal. Okay. Yeah, they did a good job.
I'm going to see the shadow of the parachute.
That may have happened in there. I wasn't watching for it.
I wasn't either.
How long did it take for Huygens to get from the top down?
I think that was real time, but I'm not sure. There was a little clock there.
2 hours, about 2 hours.
Okay, so that wasn't real time. There was a clock there, and if you watch, sometimes it was going fast, sometimes slow. So coming up, there's a mission called Dragonfly that's basically this nuclear-powered drone that's going to take advantage of the thick atmosphere and be able to travel around on Titan. And that really got a boost when we had Ingenuity, the little helicopter on Mars. People are like, whoa, wait a minute, this is a great way to get around. I know we had a member, Julian Knott, I don't know if anybody remembers him, but he was a famous hot air balloonist. And he was working with NASA, with some people at NASA JPL, to send a hot air balloon to Titan and do aerial reconnaissance. Because with a thick atmosphere, it's like the perfect conditions to do that kind of stuff. And he actually brought the program manager for that from JPL to one of our star parties to take a look at Titan because he had never seen Titan before. So it was when Saturn was up during our star party. So that was kind of cool. But sadly, Julian was doing more ballooning type experiments and was killed in an accident.
Let's have an atmosphere, the parachute wouldn't work.
Right. You need an atmosphere for the parachute to work, and a thick atmosphere is fairly nice for parachutes. Like for Mars, it's a big problem because there's enough atmosphere that if you don't use a parachute, you'll heat up and burn up in the atmosphere at the speeds you're going when you arrive there. But if you do use a parachute, there's not much air to catch it, and you have to be careful how you deploy it because you could rip it up if you're going at high speed and you haven't slowed down enough much. So that was a real thing, designing the parachutes for landing on Mars. So another cool moon out there is Enceladus around Saturn. This is similar to Europa. You can see it's got a little more impact activity on it, but you can see these tiger stripes in the lower right, they call them. So these moons are also in sync out there and flexing each other, so you can see there's tectonic stuff going on, and these cracks are where water is oozing up from below, and they're actually cryovolcanoes, ice volcanoes on Enceladus, spewing out stuff. And Cassini actually flew through some of these plumes coming off and measured the components, and they see stuff that's indicative that, again, this is a place that would be very conducive to life. So there's going to be, I'm sure, lots of exploration of Enceladus coming up. And it's got a liquid saltwater ocean, a large one underneath. It's, I believe, around 250 miles across. So this is one of the lesser known moons. This is Phoebe, and this is an irregular moon. It's in a retrograde orbit around Saturn. You know, one of those, several of the 146 seem to be captured objects, and so there are these weird tilted and retrograde orbits. And this is one of them, and it shows signs of impacts with things that were orbiting prograde, and it's very dark, and from its spectrum, it's covered with what are called polycyclic aromatic hydrocarbons, so these organic compounds that form on ice very easily. Even tiny ice grains out in these molecular clouds that we see in the galaxy, when you get these, carbon and oxygen are pretty common and hydrogen, when they get together on these icy surfaces, it acts like a substrate where they can sort of link up and form long chain molecules. So you get this stuff that's basically barbecue junk that's on your barbecue at home on these asteroids. And this moon is getting hit by all kinds of stuff. You can see the younger ice underneath there in that one crater on the right. And it's spewing this stuff out into orbit around Saturn. And so there's another moon that's really cool, Hyperion, which looks like an old sponge. And it's collecting a bunch of these polycyclic aromatic hydrocarbons, and they're dark. These carbon compounds are dark. And so it's not that this thing is getting impacted that much. There are some impact craters here. But these are, if you're like a mountaineer or a skier, you're probably familiar with it. You've got a piece of dark carbon or something on the ice. It absorbs heat from the sun and it melts its way down and makes a little conical like depression. And so that's what seems to be going on this moon. And it's also interesting because it's very fluffy in structure, and its center of, if you took a centroid of the visual part here, it's not where the center of mass is. It's kind of offset. So this thing tumbles in a weird rotation as it goes around Saturn. And so then you've got Iapetus, and this is an interesting moon because even way back in the time of Cassini, they could see that on one side of Saturn, this moon was really bright, and on the other side it was darker. And so it's tightly locked to Saturn. It's orbiting around, and sometimes we see this light face of it, and sometimes we see the dark face. And this is more of those polycyclic aromatic hydrocarbons. And there are various explanations for why they're there. I think the best one seems to be that it's stuff that they're hitting that's debris from collisional effects on these other PAH-rich moonlets that are out there. Although some people are saying, well, it was initially mostly dark, but when the dark area heats up, the white stuff under it, the ice melts, and sublimates into a gas, and then it recondenses on the other side where it's cooler. But this is tightly locked to Saturn, so one side wouldn't always be cool and one side wouldn't always be warm. So I think it's more likely that this is stuff splattered onto it because the dark part is the leading edge as it goes around in its orbit. And that's fun. You can detect that in an amateur telescope if you look at Iapetus on one side of Saturn and then on the other. And it's also interesting, you can see a very large impact there in the picture on the right. And it looks like a walnut because it has this ridge going around its equator that's 12 miles high. And so it looks like, one of those impacts, again, impacts forming moons, splattered off and formed a ring of debris and possibly moons that subsequently fell back down onto Iapetus. And when they got within the Roche limit, they, broke up. And so you deposited this nice ring of mountains around Iapetus. And they're like the third highest mountains in the solar system on this little moon. Okay, time to go to the cafeteria car on the train. This is Pan. This is one of the tiny shepherd moons that hangs around in the rings of Saturn and keeps them in shape. And it looks kind of like a dumpling because as it's going around, the plane of the rings intersects it right there, and it accretes these little pieces of ice that form this ridge around it. It makes it a fun moon. And no visit to Saturn is complete without a visit to the Death Star. So this is Mimas. This is another like 200 or 300 mile across moon with a gigantic impact. It's an icy moon. Most of these, now that we've gotten out in the outer solar system, pretty much these moons are icy. And there's cracks on the other side where, this shock wave went right through it and almost blew it apart. So that's our Death Star moon. You can't see that through a telescope, though. You've got to go out there. Okay, I'm going to give short shrift to the ice giants. So Uranus has moons that are named after Shakespearean characters. This is Miranda. You can see another icy moon, looks a lot like Ganymede. You can see there's flow, there's sort of tectonic plates, but there's impacts also. So this is going to be characteristic of most of the moons you'll see around Uranus and Neptune. But Neptune has a nice, interesting moon called Triton that looks like a cantaloupe and looks a lot like Pluto. And it is in a retrograde, highly inclined orbit. So it looks like a captured piece of Kuiper Belt stuff that got in there, and Neptune grabbed hold of it. And it's interesting because in the summertime, or spring and summertime, as it warms up, you see those dark markings down there on the lower lobe. And basically, you get cryovolcanoes of nitrogen ice. And the nitrogen compounds are dark, and they come out. And it does have an exosphere, like an atmosphere that's very tenuous. And there are actually images from Voyager that showed these plumes coming up, and then they hit the wind layer, and they just make a right angle as the wind hits them. And then they deposit this darkness down on Triton. Pluto, okay, we're into dwarf planets now, depending on your point of view. And it has 5 moons, and again, they look like they're collisionally formed. For a while, we thought there was only Charon. That was found in the 70s. But you know, since we've been going out there and taking closer views and have the Hubble, we're finding all these little pieces of junk floating around it, named after various underworld characters. And Charon is interesting. It's big. It's like the Earth-Moon system is sometimes considered a double planet, and so is Pluto and Charon. And talk about tidally locked. Charon is tidally locked to Pluto, and Pluto is tidally locked to Charon. So if you're on one side of Pluto, you always see Charon, and you always see the same face of Charon. And if you're on Charon on one side, you always see the same face of Pluto, and on the other side, you never see Pluto. So interesting dance that they're locked into. You can see this one had all kinds of tectonic stuff going on and impacts. And what's interesting is that polycyclic aromatic hydrocarbon type stuff that looks reddish here on the top implies that maybe there was a magnetic field channeling stuff that gets pummeled off of Pluto that then follows the magnetic field lines and impacts Charon. Probably at both poles, but in this case we're only seeing one of them. So this is from the New Horizons mission, which got us all kinds of interesting views of Pluto, and then went out even farther in the solar system. I don't have an image of Aerocoth, but it went out into the Kuiper Belt and saw this snowman, you know, 2 icy, sort of almost pancake-shaped objects that are in contact. And that shape was actually detected with an asteroid occultation campaign. So you can get data about these things that are far away that's more precise than even Hubble can do. And you can be stupid like me, you just go out and point your telescope at the target and take data as it winks out and winks back on, which is pretty neat. Even with my little 5-inch scope, I did an occultation of Pluto and detected its atmosphere. Not that I was smart enough to know that, but the people who analyzed the light curve said, oh yeah, it's asymmetric, and it wasn't a direct chord across Pluto, so you're seeing the different levels of the atmosphere, which is pretty neat. Okay, now we're out in the other dwarf planets out there. This is sort of going backwards in the story about these dwarf planets, but this one is Haumea, and 2 little moons, Namaka and Iaka. And also there's icy debris spread through its orbit. So this was found by Mike Brown, who was the guy that got Pluto killed. And he, because of some naming things that went on that we'll discuss with another moon here, it used to be if you discovered something, you got to name it. And now the IAU takes over naming because they don't want anybody to give a repulsive name of some kind in a weird language to some of these objects. So he was just kidding around with them because when he found Iris, when he found the 2003 UB313, which got Pluto demoted, he had a name he wanted for it, and the IAU didn't let him do it. So for this one, he proposed the name of Santa Claus. And they said no, but because it was icy and seemed to form from a collision and had a lot of, it was a parent body for a bunch of other little things, they named it Haumea, which is the Hawaiian goddess of childbirth. And her story is, as she walks along, she breaks off pieces of herself and they grow up to be children. So that's how this one got its name. But here's Iris. It's twice as far away as Pluto, so we've made it out 8 billion miles or so. And it's about the same size as Pluto, just a tiny bit smaller. And it has its own moon here, Iris and Dysnomia. And the way they got these names is, when Mike Brown first found this thing, it was 2003 UB313, I kind of fell out of his chair. He said, wow, this thing's at least as big as Pluto, it's twice as far away, it has its own moon. I found a new planet. And it used to be you got to name planets until in the 70s, an American astronomer discovered an asteroid, and he named it Mr. Spock after his cat. And so the International Astronomical Union said, okay, people aren't being serious enough about this, we're going to take over naming, but we'll take suggestions. And so Mike Brown was fond of a TV show called Xena the Warrior Princess. So he wanted to call it Xena, and he wanted to call its moon Gabrielle. That's her sidekick on the TV show. And so the International Astronomical Union got together and they said, okay, we're going to have to resolve this whole Pluto thing, because for years, for decades, people have been saying, look, you know, when they first discovered Pluto, they thought 10 times the mass of the Earth, this thing's a major planet, and every time they looked with better instrumentation, it's like, boy, this thing's getting smaller. And the joke was Pluto was going to evaporate in 70 years. And that's about how long it took. And so people have been arguing we should call it a Kuiper Belt object or something, you know, else, not a major planet. And so this kind of brought that to a head. People were saying, oh, let's just go with tradition, you know. And people were warning them, you know, hey, if you do this, you know, pretty soon we're going to have 100 major planets and it's going to be a big deal. So they got together, they argued about it and argued about it and argued about it. They came up with a really lame definition of what a planet is, and then they created a new class called dwarf planets. And they put Pluto in there, they put Ceres, the biggest asteroid, in there, because it's big enough that it's in hydrostatic equilibrium. It's kind of a sphere made out of ice. And they put Pluto in there and they put this thing in there. And so of course that caused a lot of brouhaha with people fighting back and forth. And they even argued for quite a while. So when they finally gave it a name, they weren't going to call it, you know, Xena. They called it Eris, and that's the Greek goddess of arguments. And they call its moon Dysnomia, and that's the Greek goddess of lawlessness. And the star of Xena the warrior princess was Lucy Lawless. So they got in some bad jokes and they made everybody happy. He also discovered another one that he found on Easter Sunday. And he said, okay, well, let's call it the Easter Bunny, because you know they didn't take his name, so he was a little put out. And of course the IAU wasn't going to do that, but they called it Maki Maki, which is the creation god of the Rapa Nui culture, which lives on Easter Island. So, you know, they've got somewhat of a sense of humor. And this was actually a comeback for Ceres. Ceres was considered a major planet. The first group of asteroids that were found were considered planets up until photography came along and people started to say, these things are like rats. We can't call them planets. They're all over the place. And so they created a new category called minor planets or asteroids. So Ceres was put in there, and now it's kind of getting a promotion coming back up again. And there's going to be all kinds of other dwarf planets when they finally get around to arguing with each other again and deciding what's what. And the whole thing's fuzzy. You know, they're all planets, basically. They're orbiting the sun. So, you know, science is messy. There's not nice boundaries on all these things. And, oh, I didn't quite take an hour, but I'm all done. So that was... One of the things they said was it dominates its orbit, and so that's for a planet versus a dwarf planet. But yeah, it was a really lame definition, in my opinion, and a lot of other people's opinions. But we'll see if they refine that. I hope they do.
Isn't part of that definition that it orbits the sun?
Yes, part of that is it orbits the sun.
So that all these other things that orbit other stars aren't really planets.
Well, orbit its star, you know, yeah. The comment was, you know, if it doesn't orbit the sun, it's not a planet. So what about exoplanets? But yeah, it orbits its star, and our star is the sun. I'm sure that's what they'll say, and that's probably in the definition of exoplanet. I haven't looked it up. And we think we found an extraplanet, a planet in another galaxy. That's pretty cool. M51 is up right now, and we can show it at star parties, and there's an X-ray binary system there that seems to have occultations periodically by a planet, so that's pretty cool. Everybody had enough? Yeah.
Why did that prevalence in water?
Water is very common in the universe. Hydrogen is very common, and oxygen gets made easily inside even small stars. So it's out there a lot, and they like each other. So there's lots of water, but you know, there's often a bunch of other things with it that you might not want to drink.
And
Oh, yes.
In the
cases where you have multiple moons orbiting a planet, do they orbit in the same plane, or do you get cross orbits?
Okay, so in the case we have multiple moons orbiting a planet, do they all orbit in a plane, or do you get mishmashes and weird stuff going on? Well, just like with Saturn with that, and Neptune with the high inclination and retrograde moons, if the moon forms with the planet, it tends to be in the equatorial plane of the planet, because the planet's gravity kind of, and the angular momentum when it formed kind of dominate that. But when you get captured moons, then you get all kinds of weirdness going on. So you can, if you plot all the moons of, say, Jupiter or Saturn on a sky picture, you'd be amazed how much of the sky they fill. And they're in all kinds of weird up and down, left and right orbits. It's crazy. A lot of them are captured.
Hey Chuck, can you hear me?
Yeah.
You know, Sean one night at a star party, Sean Kelly told me that a definition of a planet is a body that can clear its own orbit.
That dominates its orbit, I think is what they said, yeah.
Dominant, okay. That was no question,
Yeah.
that was my question.
Okay, yeah.
Well, Chuck, can you tell me how many space agencies are zeroing in on our moon right now? China's on its way back from the far side. We're going to go there. Artemis, Japan, are they?
Oh yeah, so how many space agencies are concentrating on our moon? Boy, there's us, there's the Russians, although there's kind of went kaput. There's India, there's China, there's Japan. United Arab Emirates has been going to Mars, but I'm sure they'll try a moon mission.
Do they have rules being established when you plant a flag? How much space, how much acreage? You just claim for your country?
So do they have rules about claiming pieces of the moon and all? Well, I think there were some agreements that not everybody signed about not being able to own the moon, just like Antarctica, but you still have people like Argentina, or countries like Argentina, that are claiming parts of Antarctica. So the concern is that some of these non-signatories will try to claim parts of the moon. I think there is a clause in that space agency dictum that says landing sites of a particular country sort of are monuments of that country. So don't go mess, Buzz Aldrin's footprints up, stuff like that. But I don't think it's well established. Just like it's not well established who can send 10,000 satellites up into orbit and make it nice.
But all those rills and craters and Mari you showed on the far side have got Russian and Chinese names now, don't they?
The rills, the craters and seas on the far side of the moon primarily have Russian names, because the Russians were the first to image them in 1959. But they're named after scientists, which was the convention. So there's other scientists there besides Russian scientists.
Well, we can't see them anyway in our telescope. Let them have them.
Yeah. Well, someday they might be nice sites for a radio telescope or something like that. Jerry, did you want?
I just thought I heard somewhere that Israel was planning with their probe.
Israel also did send a probe. Yes, I forgot that one. They sent one up that had tardigrades and other things in it, and it crashed. So there's now tardigrades owning the moon. They're pretty tough. I don't know what their flag looks like, but... Okay, rescue me, Jerry.
Well, congratulations.
I didn't know whether to get you a cup or not.
No, I don't need a mug. I've got a couple.
Chuck, from out here in Sioux Lab, I just wanted to say thank you. I have a bad cold, so I couldn't come tonight.
So that's it for the formal part of our meeting. And now have a social hour.
Where's the bar?
I don't mean that social.
Yay.